What is dynamic equilibrium? In this lesson, you will learn about dynamic equilibrium, the conditions required for dynamic equilibrium to be reached, and examples of systems at equilibrium. Imagine you are digging a hole. You got it. Imagine as you are digging that hole, your friend is refilling it. If you are digging the hole faster than your friend, the hole gets larger. If your friend is filling the hole faster than you, hole gets smaller. But if the two of you are working at the same speed, there would be no change to the size of the hole. The same concept can be applied to a reversible reaction. If the rate of the forward reaction, reactants to products, is the same as the reverse reaction, products to reactants, the reaction is said to be at equilibrium. This is called a dynamic equilibrium because both processes are occurring simultaneously, even though there is no overall observable change. For a chemical system such as a reaction or phase change to be at equilibrium, it must meet two important criteria. First, it must be reversible process. Second, it must be taking place in a closed system. A closed system is one where there is no exchange of matter, only exchange of energy. An example of a reaction at equilibrium is the reaction of hydrogen and iodine in a closed container to produce hydrogen iodide. At the start of the reaction, there is a high concentration of hydrogen and iodine, and the concentrations decrease as hydrogen iodide is formed. The concentration of hydrogen iodide increases as the forward reaction proceeds. As hydrogen iodide is formed, the reverse reaction is then able to occur. Over the time, concentration of hydrogen, iodine and hydrogen iodide remain constant. So what is happening here? The reaction of hydrogen and iodine to produce hydrogen iodide is occurring at the same rate as the decomposition of hydrogen iodide to hydrogen and iodine. So there are no observable changes, although both the forward and reverse reactions are occurring. The reaction has not stopped, but rather has reached dynamic equilibrium. What would happen to this reaction if the lid on the top of the glass jar was opened? Please pause the lesson to think about this and resume when you are done. If the lid was removed, the system is no longer at equilibrium as the reactants and products or matter would be able to escape the system. Liquid bromine equilibrates to form gases bromine at room temperature. Remember that this is not a reaction but rather a phase change. Phase change can also reach equilibrium under the correct conditions. As liquid bromine evaporates, gases bromine condenses. Since these two processes are occurring simultaneously at the same rate, there is no observable macroscopic change, but the system is in fact in dynamic equilibrium. In summary, a chemical system is said to be at equilibrium when the rate of the forward reaction is the same as the rate of the reverse reaction. There are no observable changes, but both direction of the reactions are occurring, so it is a dynamic equilibrium.